Okay, let's jump right into this explainer. We're going to equip you with the exact strategies you need to flawlessly execute ratio questions, and crucially, save precious time on the UCAT Quantitative Reasoning section. Now, we all know ratios sit right alongside percentages and rates in this exam, and honestly, they're notoriously tricky if you don't have a structured approach. But with the right techniques, they actually become some of the most reliably scored marks you can get your hands on. The brutal time pressure is absolutely your biggest hurdle here. You're staring down 36 questions with only 26 minutes on the clock. Because of that, our benchmark for success is tackling a straightforward ratio question in just 20 to 30 seconds. Seriously, even multi-step ratio questions with scaling should take no more than 45 seconds. If you find yourself pushing past 50 seconds, you've got to flag it and move on. So, how do we get that fast? Well, we've got a packed agenda today. We'll be covering mastering the UCAT calculator, the 3 ratio types, when to simplify ratios, conquering 3-part ratios, and finally, avoiding the deadly inversion trap. Section 1. Mastering the UCAT calculator. Let's start with your main tool for this section. So you have 2 options to operate the calculator in the test center. And while clicking the computer mouse is incredibly easy to practice with at home on your laptop, mastering the full-size keyboard will give you a massive speed advantage. Test centers offer keyboards with numeric keypads, and training your muscle memory to use that specific keypad is an absolute game changer for your pacing. Trust me on this. Look at how these essential shortcuts, like hitting Alt+C to open the window, can shave actual seconds off your runtime. The memory functions are absolutely crucial for those complex multi-step calculations. Hitting M+ or the letter P saves a number and MRC recalls it. Just remember to clear the memory by hitting MRC twice. Oh, and keep in mind the limits. There's no square or power button on this thing, so you're still going to need some sharp mental math for the basics. Section 2. The 3 ratio types. Let's figure out how to categorize these problems. First up is the part-to-part ratio. This is where you completely ignore the total data set and just divide one distinct portion by the other. Like, the question might ask for the ratio of nurses to doctors, or compare earnings from year 1 to year 2. Simple enough, right? Then we have the part-to-whole ratio. In these scenarios, you've got to divide the specific part by the entire total. These are often percentage and proportion questions wearing a disguise. If they ask what percentage of staff are nurses, you're setting up a part-to-whole calculation and then just multiplying by 100 at the end. Finally, there's scaling. This is where you're handed a ratio, like 3 to 7, and a real-world total, like 350. You use the sum of the ratio parts to work backwards and figure out the actual physical quantities. Section 3. When to simplify ratios. Let's look at how to actually execute the math. You have a binary strategic choice here. Basically, mentally simplify the ratio only if there's a quick, obvious common factor, like 5 or 10, or if one side easily reduces to 1. But, and this is important, if the common factor isn't completely obvious, or if the answer options are decimals, do not sit there trying to find a common denominator. Just use the calculator. Divide the left side by the right side immediately and match the resulting decimal to your answer options. Save your brain power. Let's test this strategy with a classic part-to-part question. Take a quick look at this and think about how you'd set this up. A hospital ward has 180 nurses and 45 doctors. The question asks for the ratio of nurses to doctors in its simplest form. Okay, so the crucial point is that by properly assigning the numerator nurses first and using a quick mental benchmark check, you arrive cleanly at the right answer. Notice step 2 there, the benchmark check. 180 is definitely larger than 45, meaning the left side of our ratio must be greater than 1. This quick eyeball test instantly eliminates trap answers. Then, since both are obviously divisible by 45, we simplify and get 4 to 1. Boom, done. Section 4, conquering 3-part ratios. Let's crank up the difficulty a bit. 3-part ratios tend to paralyze a lot of test takers unnecessarily, just because the standard fraction format suddenly looks kind of alien. But by strictly applying this sum of parts method, you strip away the confusion and make finding any piece of a multi-part ratio an automatic reflex. The biggest mistake students make is trying to form fractions between individual parts without first establishing this sum. So rule number 1, always add everything together first. Here's a scaling question with 3 parts. A hospital budget of £120,000 is divided between 3 wards in the ratio 2 to 3 to 5. How much does ward C receive? Remember the rule we literally just talked about and apply it here. Let's see how the math builds out. Finding the true denominator of 10 is the master key that unlocks this problem. Word C represents 5 parts, so that's 5 out of 10, or 0.5. Multiply that by 120,000, and you get the correct answer, 60,000 pounds. Listen, test makers intentionally plant trap answers, like 54,000 pounds, which you'd get if you panicked and divided by the wrong portion, like 9. Don't fall for it. Section 5, the deadly inversion trap. Defensive tactics time. We are in the final stretch, and it's time to talk about the most costly error in the entire QR section. The exam is specifically designed to punish you if you divide in the wrong direction. Writing these 2 vital rules down on your whiteboard takes literally 2 seconds, but it prevents you from falling for their trickiest traps. The word to identifies the left side, the numerator. The word of identifies the whole, the denominator. Actually write your numerator and denominator labels down before you even touch the calculator. Take a look at this comparison question. Hospital X has 12 consultants for 300 patients. Hospital Y has 9 consultants for 198 patients. Which hospital has fewer patients per consultant? The trick here is entirely in the wording. What does patients per consultant actually mean mathematically? Because the question specifically asked for patients per consultant, we absolutely must divide the number of patients by the number of consultants. Doing that proves Hospital Y, with 22 patients per consultant, is the correct answer. The inversion trap here is strong, guys. If you just blindly divided consultants by patients, you'd get trapped right into picking Hospital X. Bypassing this trap is all about reading the specific direction of the wording. So, what should you take away from this explainer? These 4 non-negotiable habits. 1. Eyeball your benchmark check first. 2. Use the calculator divide method when things get sticky. 3. Always sum the parts first on complex ratios. And 4. Take 2 seconds to label your numerators. These habits literally turn UCAT ratios from a stressful time sink into quick, reliable points. You've got the expert toolkit now to break these down in under 30 seconds. So the question is, when that timer starts, will you be the one who falls for the inversion trap or the one who completely beats the clock? Keep practicing, get those reps in, and I will see you in the next explainer.